All right, so in the next two questions, I ask you to think about how to write the powers of 5 and multiples of 5. So, look at your sequence and really dig into what's happening here. Okay, so how do we get from this term to this term? Well, looks like we multiplied by 5. How do we get from this term to this term? Again, it looks like we multiplied by 5. How do we get from here to here? Well, once again, we're multiplying by 5. So what's happening here is we're saying take 5 and multiply it. So, okay, so we start out with 5, which is just 5 times itself, right? And then we get 25, which is 5 times 5. Then we get 125, which is 5 times 5 times 5. And then we have 625, which is 5 times 5 times 5 times 5. And another way we can write each of these is 5 to the first power, 5 to the second power, 5 to the third power, 5 to the fourth power. And if you look, what n is in each of these parts, so this is n is 1, n is 2, n is 3, n is 4. And when you start to compare how we wrote our expression here and the value of n, you can see what's changing in each of those expressions is the exponent on 5. So we can write this expression then as we can write that expression as a sub n equals 5 to whatever the term number is, and that's our power. Now with multiples of 5, so this is a little bit different because to get from 5 to 10, we multiply by 2. To get from 10 to 15, we also, we're not multiplying by 2. That's interesting. So let's start over. So we're not multiplying by 2, right? Because it's not consistent. So let's see. We added 5. Maybe that'll work. From 10 to 15, we added 5 again. From 15 to 20, oh, look at that. We added 5 again. So this time we're starting at 5 and we're adding 5 every time. So that repeated addition is similar to a multiplication, right? So we could say here we start with 5, right? And then we take, to get 10, we take 5 and we add a 5. But then to get 15, we start with our first term, which was 5, but then we add 2 more 5s. And then to get 20, we start with 5 again, but then to get to 20, we add 3 more 5s. And you can start to sort of see how this is sort of shaping up. This value, so let me rewrite that second term a little bit here. What if I wrote that as 5 plus 1 times 5? Okay, and then 5, just 5. So there's two ways we could write this. If you start to sort of see what's happening here, what we really have is 5 plus whatever we're adding each time, which is 5, times, now this value, just like in the previous problem, we were able to kind of match up. Let me write our n values above here. N equals, this is n equals 1, n equals 2, n equals 3, and n equals 4. If you start to compare those, comparing n equals 1 to 5, there's no real n value showing up there, but n equals 2, I've got this 1 here. When n equals 3, I've got this 2 here. When n equals 4, I've got this 3 here. So I'm really saying whatever n is, subtract 1 from it. And that's going to be what you'll multiply by. Now that's one way to write this. Another way to write this is to go back to what you learned about in Algebra 1. And you talked about writing your sequences as the 0 term plus the rate of growth times your x value. In other words, so we would take our 0 term, which I don't know, I'll come back to that. But to that, I'm going to add my rate of growth, which is 5. That's really just our slope, times n. But our 0 term, well, if this is our first term, is 5. If we work backwards 1 and subtract 5 from that, we get 0. So our 0 term in this case is actually 0. these two things are actually equivalent to each other, and either one of them would be okay. But this is how we can come up with an equation for that. And what you'll see in the next lesson or two is actually diving more closely into writing arithmetic sequences. So we'll be able to kind of get into that a little bit more.